Hi everyone, I'll be explaining my project, Machine Learning Application to Estimate Battery State of Charge. I am Talha Kamran and this is the part of 990B project presentation. As you all know, this was divided into three parts, so me, Andrew, and Namesh will all be having three different presentations to explain this project. And this is in continuation to the machine learning models project that we did in 990A. Let me quickly go through the outline of today's talk. So I'll be talking about the introduction of our whole project and then the problem statement of the project and the problem statement that I have for my part, the motivation behind it, the objectives, background, and then the Flask application architecture that I developed, the prototype development, methodology, and then I'll be telling about the testing that we did on the server API, results, conclusion, and then what's the future work that we can do on this. In our last semester, we worked on estimating the state of charge of an LG lithium-ion cell using machine learning methods. We performed training experiments using several neural networks such as DNN, CNNs, and LSTMs. To expand on our machine learning research from the previous semester, we considered several options. We decided, with the help of our supervisor, to go deeper, primarily by creating a ML application that anyone with internet can access and find value. Whereas another aspect was to research and find the feasibility of incorporating TensorFlow serving or the Flask RESTful API to our web application. So an internet search for a similar SOC application does not return any results, indicating that our work is novel. So this is basically our problem statement, that we had to develop an ML model deployment and also to implement it and incorporate it into a web application. So ML model deployment using Flask API adds flexibility to our work and makes it a finished product, whereas the proposed model can be implemented in real-time applications including EVs and renewable energy systems to monitor batteries SOC. While the broader objectives of our project is to create a web application, implement the Flask RESTful API, and also to incorporate the Panasonic dataset into the LG dataset that we did in 990A. But the objectives that I have in my part was to create a machine learning application and do the backend programming of it, and then incorporate the client API which was provided by Flask. This model deployment ensures faster processing time and low web page loading times. To quickly go through the background of machine learning model deployment, there are two ways to do this. First is Flask and second is TensorFlow serving. Flask is a Python-based web framework that provides users with a range of tools and libraries for building web applications, whereas TensorFlow serving is a powerful adaptable system for serving machine learning models that is well suited for use in real-world production settings. Our project is deployed using Flask because Flask is commonly used for prototypes and by universities because of its simplicity, whereas TensorFlow serving is simple to deploy new algorithms and conduct experiments while still maintaining the same server and architecture, but it's really complex. The figure shows the Flask application architecture. So it consists of a Flask application server, and then a GET request or a POST request can be sent, and then the predictions or output can be received. The libraries and functions that are used for coding are Flask RESTful, which is the library used for making API, then ngrok, which is a library. It establishes a secure channel with Flask and end user by creating a tunnel. The ngrok also provides a new IP. Then the JSONify function was used to convert data into JSON format, and then it was required to send a request to the server by using the request function, which inputs URL and then request is being sent. This slide shows the prototype development for Flask application. As the figure shows that the Flask application is working and it is a development server, so it shouldn't be used for a production deployment. So the server is run on localhost IP with port number 5000. This is a free to use IP for everyone. The response at the end, get HTTP 200 response, it means that the connection to the server is successful and it is returning a successful response. The new IP that you can see in 6th line, it shows that ngrok has established a secure channel with Flask and end user by creating a tunnel. The working methodology of Flask server is really simple. So in the request we send a dataset as input, which is converted to JSON format. Then this JSON, when it reaches the Flask application server, it is converted back to data frame, and then the machine learning model is applied on the data frame inside the server. Then the predictions that we get are changed back into JSON format, and then that JSON is sent back to the request format as a response. And then this JSON response is converted back to array, and then this array is plotted as array predictions. In this slide, we are testing the server API. So first, to test it, we send a GET request, because GET requests are really simple. You do not send an input with a GET request. So when the GET request is sent, the server should return the line server is running, which is our output, which also you can see in the figure. That was our coding. And this GET request is set to path /hello, which was set by myself. And then this is followed by the URL in which the server is running. So as you can see, the output is correct, which shows that the server is serving its purpose correctly. After testing the GET request and to see if the server is working or not, we jumped on to our results. So we sent a post request in which we send the dataset that we had to the server and to see if we get the response back. So when we send the post request to the Flask server, this kind of request inputs a payload which consists of test dataset, and then this dataset is converted to JSON and then passed to the server. The server should convert it back to data frame and apply the machine learning model to it. Then the predictions are converted to JSON, and then they are returned as request output from the server. Then these outputs are converted from JSON to array and then printed as a graph. As you can see in this slide, the first figure, it shows our coding and what our server is supposed to do for a post request. So the post request has the endpoint /predict, which you can see in the second line, and then the coding inside shows that how the JSON is being made, and then the machine learning model is applied, and then the predictions are converted back to JSON and then returned in the last step. The figure below shows the response that the server is making. So it shows that the server is working. It is working on the ngrok IP that was provided by the secure channel. And then in the end, all those last lines, you can see that when the predict function, which is the post request, when it was sent, it returns a 200 response, which is the correct response. Now we will see what the output looks like from the server. The output that was connected by the server, it is in a JSON format. When this JSON format was converted back to an array, then this array is plotted against test labels that we already had from the dataset. So in this case, I showed the figure for the CNN model. As you can see, the predictions are correct, and the SOC prediction and the actual SOC is really close to each other, which shows a really low error. So I won't go into the details of the prediction because we already did it in the first semester in 990A. Over here, we just need to see if the server is working and if this backend programming that we are doing, does it save us time and provides the correct result for the web application. In this slide, you can see when the Flask API was incorporated into the web page, which was coded using Python on Streamlit, the server perfectly handles requests and reduces processing time and gives flexibility for future modifications. You can see in this figure that the front end of the web application is shown, and then when we upload a CSV file or the dataset file, it returns the output on the right. So it means that the server is working correctly and it is getting the input as the dataset, and then it's applying the machine learning model on it and returning the correct response. More details of the front end of web application are provided by Andrew. Some of the project constraints that we faced were hardware constraints, which was RAM and GPU limitation, and then the software constraint, which was that we were using a free version of Google Colab. So Google Colab only provides a limited amount of RAM and GPU. The network IP constraint that we faced was that we were using a free IP and free port 5000, So it was only used for testing and prototypes, but Google does not allow these network IPs. That's why we had to use ngrok for this purpose. And then some of the time constraints were that the training time of our machine learning models is too long. So machine learning model deployment is essential for production environments and industries. Our ML model deployment using Flask application server. This server works perfectly as you can see in the previous slides, but runs locally. This demo shows that the deployment is possible, although for more professional environments, paid server IPs will need to be purchased. The advantages of using Flask application are that models are already loaded in another server, and therefore any request from web page to this server will result in faster processing times and reduced lag. The disadvantages include local server, which demands constant running of this application of Google Colab Notebook on my PC. So in conclusion, model deployment on Flask is successfully demonstrated and incorporated on our web page, and then the front end of our application is described by Andrew in another presentation. While the backend programming is done, future work includes testing the web application for errors and glitches and troubleshooting, and then adding more functionality to the application. It also includes finding ways to add machine learning model deployment to the web application by going past security checks and efficient programming that reduces loading times. Model deployment on Flask is successfully demonstrated, but then its full potential is yet to be explored because we are using a free IP. This slide shows some of the references that we have for this project, and the full list will be available on the project report, but here you can see some of the main key references. Thank you so much for listening to my presentation, and I hope you all have a good day, and if you have any questions, feel free to reach me out and I will answer it. Thank you.